Hi everyone. Today I've decided to continue my series on irritants and tear gases. In this video we're going to talk about pelargonic acid morpholide, MPA. Here is its structure. It's a very interesting and quite potent irritant. Structurally it resembles capsaicin and acts in a very similar way. According to the literature, it is 5 times more powerful than CN, chloroacetophenone, but weaker than capsaicin. Due to its virtually non-existent toxicity, it was even proposed as a food additive to replace capsaicin, though it's not currently used for that purpose. The only place it is widely used is in self-defense products in post-Soviet countries. You can find it in gas canisters, either on its own or mixed with CS. Outside the former Soviet Union, this substance is practically unknown. Canisters containing only MPA are generally considered ineffective. It's not that MPA is a weak irritant, it's actually quite strong, as I mentioned, stronger than CN. However, being a capsaicinoid, it has a very weak lacrimatory, tear-inducing effect. This, combined with the low concentrations allowed by law, makes pure MPA sprays unreliable for self-defense. On the other hand, mixtures of MPA and CS are very effective, as MPA complements the effects of CS perfectly. That's enough theory. Now let's synthesize it. For the synthesis, we need morpholine and pelargonic acid. I bought the morpholine at a chemical supply store. For a while I didn't know where to find pelargonic acid, but then I discovered it's used as a herbicide. I found a Polish herbicide that contains 70% pelargonic acid, with the rest being some kind of emulsifier. Isolating the acid from this mixture was easy. I tried 2 methods, steam distillation and extraction, and both eventually worked. So here is the pure pelargonic acid. It's cold here, so it has crystallized. Usually, to synthesize a morpholide, you need to activate the acid, for example, by synthesizing its acyl chloride and then reacting it with morpholine. I'm not going to do that because I found a much simpler method. Here is the paper. Boric acid catalyzed amidation. The gist of the article is that when boiled with a catalytic amount of boric acid, an amine and a carboxylic acid form amides. I tried this reaction, but unfortunately, boric acid alone didn't start the process. However, I enhanced its catalytic effect with phenol and the reaction kicked off. So I mixed 5 mol% of boric acid with 15 mol% of phenol in xylene and boiled it to form a borate ester, which acts as the catalyst. Then I added equimolar amounts of morpholine and pelargonic acid and continued boiling. Water was released during the reaction, which I collected in a Dean-Stark apparatus. After about 15 hours, the water production stopped. The mixture was then cooled. To break down the borate ester, I added a potassium carbonate solution and stirred it for a couple of hours. Then I drained the lower aqueous layer and evaporated the upper layer under vacuum. Results. Here is the morpholide after evaporation. It's still not perfectly pure. It contains traces of solvents and a bit of phenol. Ideally, it should be vacuum distilled, but I don't have a pump that can reach 1 millimeter of mercury, so I'll use it as is. MPA is a strong irritant but has relatively low volatility. If you smell it, it only slightly irritates the nose. To create an aerosol, I mixed it with my ammonium nitrate and wood shavings mixture, just like I did with capsaicin. The effect was quite powerful, though slightly weaker than capsaicin. By my rough estimation, the MPA mixture was about 2 to 3 times weaker. That's all I wanted to say about pelargonic acid morpholide. Since I've found a source of nonanoic acid, the next thing I want to synthesize is nonivamide, or PAVA, a synthetic capsaicinoid used in medicine and self-defense. Subscribe to my Telegram channel. I post updates there earlier than they appear on YouTube.